Does more data mean more information? Not necessarily, and this is especially true for real world sensor data, which has a lot of structure to it. Let's look at some examples. So here we are looking at a time series sensor data, and the raw data is called X. We can learn latent representation, which is a smaller dimensional representation called S. And there are techniques like the inverse Fourier technique to go back from S to the raw data X. We will call this as learning from 100% of the raw data. Now in the alternative scenario, we are looking at learning from a fraction of the raw data. So in this case, we essentially only work with undersampled measurements of X, which we call Y. It is possible to go from this Y to a good latent representation S, and counterintuitively, it is actually possible to go from S back to X, which is the original data. So in principle, we are able to go from just 10% of the raw data to the entire raw data by exploiting structure in these types of data. What this means is that in a lot of real world sensor data sets, collecting 100% of the raw data is equivalent to 10% of the raw data, because more data does not mean more information. Instead, more data is redundant because we are not learning any better representations by collecting more than a certain fraction of the raw data. And all of this because we can exploit certain structures which are present in these data. As you can imagine, this has significant implications for the design of AI for the physical world across satellite data analysis, drones, industrial machines, underwater applications, and so on, because it significantly reduces the computing power, storage, transmission, bandwidth, and latency requirements to process sensor data in real time. I am Ankur from Lightscline. You can click below in the description to learn more about the work we are doing. Would be happy to discuss more about your use cases and if we can help. Thank you.